Learning goal 25 is going to be looking at joining like terms in a linear equation. So in 24, we took a look at how do we solve a linear equation when we know the output, but we need to know what that input is. So we're trying to find, in this case, we're often looking for x. And so we're looking for x and we're trying to figure out what is x. And that is where we are kind of trying to solve for. Now we're going to take a look at what happens if there are two different terms that have an x value and making sure that we combine them into like term or combine those like terms before we can solve for the variable. Let's do a little bit of review here. A linear equation, okay, is used to solve a problem which has variable components. Okay, so it has variable components, meaning that we're using letters to represent where a number should go. Okay, we're using letters to represent where a number should go. Therefore, the solution is dependent on the input value. Okay, the solution is dependent on the input value, meaning that depending on what we input into our equation, the output will change. Now, if we know the input, we can find the output. If we know the output, we can determine what the input is. And as I mentioned here, if the input value is known, so that's usually our x value. Now, it could be really any other letter, and today we're going to look at what happens if it's a different letter, and really just it's the same thing. We're just solving for that letter. If the input value is known, then the solution, or in this case usually y, can be found by inserting the value in for the variable and solving using order of operations. Now, a couple things just to be aware of. The output is going to be the one that is isolated. Okay, so isolated means that it's all by itself. So often we've said like the y is isolated, it's by itself. That's our output, that's our solution when we're trying to solve using our input value, or usually what we would consider to be our x. Now the solution, if the solution is given, okay, finding the input variable is done by isolating the variable, but we have to try to solve for the variable. We're isolating that variable. Now we remember that isolating the variable is done by removing the operations being applied to the variable. Now that maybe we can just slide this thing over here. So there we go. That works. We got to remove the operations that are being applied to the variable. So we got to try to isolate the variable. We got to remove those operations. To remove the operation, the opposite operation needs to be done to both sides of the equation. So we have to do the same operation to both sides of the equation, which will remove it from one side and place it onto the other. Okay, so really what it's doing is just moving it from one side to the other, but it's going to look slightly different because we're going to have the opposite. So if instead of adding, it's going to also be subtracting, or instead of multiplying, it'll be dividing. Whatever the case, it'll be the opposite. If a linear equation has like terms, they can be combined to solve for the missing, before we solve for the missing variable. Okay, so if we do have like terms inside of an equation, we need to combine them before we can solve. Today, or in this lesson, we're only going to take a look at what happens if we have the like terms on the same side. Later on, we'll look at what happens if we have like terms on opposite sides and how we combine them in that case there. So here we're going to solve for x. We have 3x and we have 2x, and when we add those together, it's going to be 45. So first thing that we do, okay, number one is we combine the like terms on the left side of the operation. Okay, so we're combining the like terms on the left side of the operation. Now, the like terms here, we have 3x and we have 2x. And so this is going to combine to be 5x's, right? So we can combine them to say 5x now. Let's make that into a function. 5x is equal to 45. So we combine them together. Because they are alike, we can combine them. Anytime we have like terms which are being added or subtracted, we want to combine them just to make it a little bit simpler and just to kind of make it so we actually can solve for the variable. Okay. Once we've combined them, then we use the opposite operations to solve for our variable. In this case, we're solving for x. Okay, so we combined and then we can solve. Now, this one here, we can see that the 5 is being multiplied to x, so the opposite operation is to divide by 5. And again, when we multiply or divide something, we have to do it to both sides. We actually have to do it to every single term. Okay, so every single term we need to divide by. And so here when we divide by 5, this becomes a 1. So we have 1x. And let's put that into here. So we have 1x remaining. And then on the other side, on the right-hand side, we have 45 divided by 9, or sorry, 45 divided by 5, which is 9. And so our answer is that x is equal to 9. Now again, when like terms are in an equation, they need to be combined before we're solving. Okay, so we need to combine them before we solve. Let's do a few examples here, and I have a number because I want to show you a few different things that you might see. But let's try solving these examples. So first things first, if we see that we have like terms on one side, on either the left or the right-hand side of our equation, we need to combine them first. So in this case here, we have the like terms y and negative 2y. And so we need to combine these before we can do anything else. Now, y minus 2y, so we have 1y here and we have negative 2 here, is going to give us negative y. Now, the other side doesn't change. That side still stays the same. But now we have negative y is equal to 13. Okay. We're still wanting to isolate for y, which means that we need y all by itself, and it's kind of attached to this negative sign. We're being told it's a negative y, and we need to get rid of that negative. And so what we're going to do is to get rid of a negative, we divide by negative 1. Okay, so we divide by negative 1 to remove the negative sign. Now, remember that there's actually a negative 1 in front of y, so this negative here and that negative cancel out, and we're just left with positive 1y. And on this side here, we are left with, we're going to do 13 divided by negative 1. So when we divide there, we're going to get y all by itself on that side. And now any number divided by negative 1, we switch the sign. Okay, we switch it. So if it's a positive divided by negative 1, we change it to negative. If it's a negative divided by negative 1, we change it to positive. This was a negative. We divided by negative 1, became a positive y. A positive divided by a negative 1 becomes a negative 13. And so in this case here, y has to be negative 13 as our final answer. Now again, we could double check. We could put it back into the equation, and that would tell us what it is. I won't be doing that in this video here. All right, next one here. We have 3c and 1c, and they're on top here. Okay, they're on top, so that means that we actually have to combine them. So what we're going to do is we're going to combine these two together, and I'm actually going ahead a little bit here with what we might see later on. But when we combine them, there's going to be 4c over 8 is equal to negative 4. Now, one thing that we can see here is that we have a 4 divided by 8, and we can actually simplify it. Think of it as a fraction. We can simplify that by dividing both those by 4, and it becomes 1 over 2. Okay? And what that changes, and again, this is going maybe a little bit ahead of, and we'll get into this a little later on. Okay? We're going to get c over 2. And now it just becomes a division statement. Okay, now it becomes a division statement. To get rid of the 2, We're going to multiply both sides by 2 because we're dividing by 2. So we multiply this side by 2. And when we do that, the 2's cancel out. So we're going to be left with C on this side here. And on the other side, we have -4 times -2, or times +2. And so our answer is C is equal to -8. C is equal to -8. The third one here, we have 3G and 2G. And no, these are not types of cell phone service, 3G and 2G. These are just happen to be our terms. We're using different variables here, you'll notice. Instead of using x's, I'm using g instead. So we're solving for what g is here. When we combine these two, we have 3G and 2G, and we're going to combine that to be 5G. Okay, so we combine that to get 5G. So that is that's the combining of our terms. Now the next thing that we need to do is we need to get that g all by itself, and now we're multiplying by 5. So the opposite of multiplying is to divide by 5. There we go. And we divide both sides by 5, which means that this side is going to cancel out. And when that cancels out, it's going to get g all by itself. And then we're going to have 12 over 5, which is a division statement. Now, 12 over 5, there's two different things that we can do. Number one, we can leave it as a fraction the way it is. 12 divided by 5 is just a fraction. We can leave it like that. Or we can use our calculators to solve it as a decimal, but it may not be as exact. In this case here, it will be. If we do 12 divided by 5, this is going to give us 2.4. Just had double check, did that mental math, but so we can say that g is equal to 2.4, or we can say that it's 12 over 5 as a fraction, or we could say that it's 2 2/5. Okay, that would be another way that we could leave it. But as long as we have an accurate answer, that's what we're looking for. Okay, as long as we have an accurate answer, that's what we're looking for. All right, last example here, number 4. 6 is equal to 2e minus e. You'll notice here that now we've put our variable on the other side, and that really doesn't matter as long as we just continue to do everything the same way. Combine our like terms. Okay? Combine our like terms. We want to get e all by itself, so we've got to combine our like terms. And when we combine them, the 6 is going to stay on this side all by itself. And on this side here, we have 2 e's and we have -1 e. So it's 2 minus 1, which is just 1. So it's 1 e. Okay, it's just 1 e. Now you'll notice here that we've actually already solved for e. We didn't have to do any multiplying or dividing. We just had to combine our terms. And in fact, we get that e is equal to 6. And that is the end. Now for your assignment on this little part here, I want you to work on questions 1 through 4. Okay, questions 1 through 4 are solving. If we have decimals, you can gladly use a calculator. If you have really big numbers, you can use a calculator. For smaller numbers, please try to do it without using a calculator and solve it using mental math.